Okay, so now that we talked about the and probability, now we're going to talk about the given probability and how to find that equation itself out. Okay, so the given probability is event B happening given event A has already happened itself, right? When it comes to it. So for this one, it's called conditional probability. So it's the condition that the one event has already happened to begin with. And again, we talked about that earlier, right? It's taking the card out, putting it to the side. We're assuming that already happened and see what's actually after there. Now, the good thing about these proper probabilities, we have three total probabilities we've done so far, right? The basic probability is the basic one. The or is addition. The and is multiplication. And the given is division. So we're dividing here. So quick little review summary here. So when it comes to or, we add. When it comes to and, we multiply. And when it comes to given, we divide. And again, it's isolated, so they do not overlap. It's a hard line between them. So wherever you see this or this happening, you're adding. This and this happening, we're multiplying. This given this happening, we're dividing itself. Okay. So when it comes to that, we have the probability of A and B on the top divided by the probability of A. So when it comes to this type of probability, the order of which the question phrase it does actually matter big time. Okay, so in our case, when it comes to it, I'm going to give you guys a quick little rundown of how it's going to work. Is in the question itself. So let's say this is question. So it's going to say the probability dot 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 given dot 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 to finish it up. Okay, so that's going to be like the wording of the phrasing. Everything before the word given is going to be your event B. Everything after the word given is going to be your event A. So it doesn't matter. It's not A, B, like we've done so far. The order which this does actually matter, because when you divide by the bottom number, it makes a huge difference either probability of A or probability of B. Okay. So when it comes to the givens, these are the most difficult because of this portion right here. You must always remember your event A is after the word given. Your event B is always before the word given. Okay. And that's always going to be the framework of it, as you'll see it right here in this example here. Okay, so we go back to our, our purchases, made in America portion. So here they say made in America, right? When it comes to more likely, less likely, or near less likely to figure out. And here are the age groups respectively when it comes to this question here. So question A says, what is the probability that a randomly selected individual is 45 to 52 years of age given, here's a word given, the individual is neither more or less likely to buy the product emphasized made in our country. All right, so the first thing you want to do is define what we have. So everything before the word given is event B. So this is all our event B. Everything after the word given is our event A, which means this is our event A. And notice that's how we label it down here. Event A is neither more or less likely. Event B is 45 to 54 years of age. Now remember, the reason why we do this, now we go back to our equation. The whole process is defining this number, and we need two probabilities, and then we divide them. So the first thing we got to figure out is what's the probability of A and B. So when do they happen at the same time? So how many people, in other words, right, are 45 to 54 years of age, so here, and also said neither more or less likely? Well, that should be 163, right? That's how many people are between ages 45 and 54, and also said more or less likely. So that's how we get the first one. So 163 divided by the grand total of 2253. So that gives us 0.07. This number is just the top number. Okay, that gives us just the top number answer. Next, what we have to do is define the bottom number, the probability of A. This is where it gets so important, because notice we do not ever care of finding the probability of B. We care about finding the probability of A, neither more or less likely. So how many people said neither more or less likely? 785 over 2253, or a grand total of 0.35. Okay. Now, to get our final answer, right, we want the given portion. It is 0.07 divided by 0.35, just like we have it here. which means this is our final answer there. Hence the reason why these are the most difficult, because there's the most work implied, because we actually need to find two probabilities just to get the answer itself once we divide them. Okay, and the key thing is knowing this portion and that portion itself. Okay, so let's try one together itself. Okay. So B says, what is the probability that a randomly selected individual is neither more or less likely to buy a product emphasized made in America, given the individual is 45 to 54 years of age? So notice I just swapped it, right? I just flipped the cases. So I'm going to give it a quick minute. So write down what is your event A and what is your event B. Quick to pause. Okay. So hopefully you guys did it. So event A should be this. Event B should be everything before, right? So notice that I literally just flipped this camera. So I literally just flipped them, right, when it comes to it. So this is our equation, right? That's what we want. So first thing is we want the probability of A and B. So again, question is how many people, according to our data, are between the ages of 54 or 45 and 54 and also said neither more or less likely. Notice it's the same number, right? 163. So the first probability is the same, 163 over 2253. So that gives me 0.07, right, from this last problem. Now we want the probability of 8, right? Again, always going back to the equation, right? So if you're ever stuck, right, you have the equation, right? Just follow the directions that the equation tells you to do. So we found the top number. Now we need the bottom number. Now remember, in the last example, the probability of A was neither more or less likely. In our example here, the probability of A is someone who is between the ages of 45 and 54. Like I said, they swap places. It's not always going to be that portion. So how many people are between the ages of 45 and 54? 582 over 2253. So 582 over 2253. Okay. And then once we divide them, we get the decimal itself. So approximately 0.258. Okay. And now we get our final. So the probability of B given A, which is what we're looking for, is 0.07 divided by 0.258. So approximately 0.271 is our final answer. So notice a huge difference from answer to the answer, right? The last answer was 0.2. This was 0.27. So the order in which stuff is given to you does matter dramatically. Okay. So I know these are pretty difficult. That's why we're going to take our time when it comes to these sections here, right? So now let's go to question 7. Okay. So question 7. So here's our smoking, non-smoking, and someone who's died is alive, right? Information. Question A is, what is the probability of someone being a smoker given they died? All right, the word given. All right, and then actually, why don't you guys do this? For question A and B, go ahead and write down, respectively, what's your event A and what is your event B. A quick pause. Okay, so hopefully you guys respectively found these. So this one should be your event A, this one is B, this one is B, and that one is A, right? So notice they swap places just like the last question, right? Okay, so we want the given. So again, going back, we want A and B. So what's the probability of A and B? So again, how many people died? So all of these people, how many people died and also were smokers? So how many people died and also were smokers? 139, right? So 139 out of a total of everybody put together. So I don't have that total. 1314. There you go. Okay, so 139 divided by 1314 gives you approximately 0.106. So that's the probability of A and B. So now we want the probability of A. So the probability of A is how many people died. So according to our data, how many total people died? So that'd be 139 plus 230. So a total of 369. So dividing that, we get approximately 0.281, which means our final one. So probability of B given A is division of these two, right? So 0.106 divided by 0.281 is your final answer. So approximately 0.377. And there we go. So again, right, it's pretty difficult. You gotta take your time when it comes to these ones here. Okay. So why don't you guys try B now down here?